All right, welcome, and now let's do an example. And so here's the example that they're giving us. So here's f of x, and part A says determine if the upper bound okay, so it says determine if the upper bound theorem identifies 2 as an upper bound for the zeros of this polynomial. Okay, so now what we're going to do, since they're telling us, okay, they're telling us 2. So they're giving us 2 and they want us to say, or determine if 2 is an upper bound for the reals in this case. So that's our c value. So in other words, we're going to divide this polynomial by x minus c, which would be x minus 2 in this case. And so now, since it's a binomial term with a leading coefficient of 1, we can use synthetic division on this case. So we're going to use 2. So 2 is what we're going to test. Okay, so we're going to do the coefficients. And again, make sure we have some placeholders here. So it would be 2, and then 1, and then 0, and then 9, and then negative 32, and 20. Okay, so now I'm going to use synthetic division, right? So I'm going to drop the 2, and that'll be 4, and then 5, 10, 10, 20, 29, 58, and so this will be oh, 26, right? And then this will be 52, which will give us 72. So just double check, right? So we drop down 2, 2 times 2 is 4, plus 1 is 5, times 2 is 10, plus 0 is 10, times 2 is 20, plus 9 is 29, times 2 is 58, and then we're going to add to negative 32, which is going to give us 26, times 2 is 52, which gives us 72. Okay, now, as we go across, what's the rule? So if we're talking about upper bounds, right, the c value 2 is greater than 0, right? So we're looking for all non-negatives here. And since everything here is non-negative, right, the coefficients of the quotient along with the remainder are all non-negative. So since they are, then this satisfies the requirements of the upper bound theorem, lower upper bound theorem. So this identifies 2 as an upper bound of the reals. Okay? So there are no real zeros that are bigger than 2. All right? So now, B says, okay, use the upper lower bound theorem for reals to see whether negative 2 whether negative 2 is a lower bound. Okay, so we're going to test -2, right? So again, we're going to use our coefficients. Okay, right? So 2, 1, 0, 9, -32, and 20. So now what we're going to do is do the same thing. Synthetic division, right? So we're going to 2, -4, -3, 6, 6, -12, -3, 6, -26. Is that right? Yeah. -26, 52, 72. So let's just make sure we did this right. Okay, we got 2 drops down. -4, -3, +6, 6, -12. So plus the 9 gives us -3. Right? And then times 2, -2 is 6, plus the -32 gives us -26, which gives us +52, which then gives us 72. Now, in this case here, because C is negative, and we're interested in the lower bound, we want to look for alternating signs. So all the way across the bottom, so the quotient, coefficients, and the remainder, right? So we go across the bottom, and we should have alternating signs all the way across. And as you can see, we don't, right? It stays the same here. So here it's positive, negative, oops, negative. So we're done. Okay? So therefore, -2 is not a lower bound. For the reals. So we could try something else, right? We could try, I mean, I'm just gonna, what about -3? Maybe we could try -3. Right? So let's go, we can do -3, right? So let's do it with -3 just to see. I don't know if it'll work, but let's do -3. So 2, so now -6, -5, 15, 15, -45, and so we get -36. We get, well, 3 times, -3 times -36 is 108, right? And then, so then we add, right? So this is going to give us 76. And then -3 times 76 is going to be 228, -228, which is going to give us -208. And now, if we see here, it's positive, negative, positive, negative, positive, negative. So now in this case, it does alternate signs. So we just showed that negative 2 is not a lower bound for the reals of this polynomial, but negative 3 is. All right. Have a great day.